And we're back with another PicoCTF challenge. This time, more cookies, a web exploitation challenge. Really as much crypto as anything, and frustrating. Holy shit. Description. I forgot cookies can be modified client side, so now I decided to encrypt them. Okay. And we're told, we're given this link to homomorphic encryption. And the search endpoint is only helpful for telling you if you are an R admin or not. You won't be able to guess the flag name. All right, so let's go ahead. Let's click through. Let's take a look at what we have. And we've been given the hint that this is about cookies. And I have a prior video where I explain what cookies are in more detail, which I'll link above, below, somewhere. So clicking into the inspector in the storage, we can see we have a cookie that's been assigned called auth name. And when we click on it, we can take a look at what this guy is. So let's go ahead, let's make a new file, text file, let's dump that here. And immediately, because there's an equals at the end, it looks like base 64. So let's go ahead and let's see what this is. Using our rapid table decoder, we'll go over here, we'll put it in the base 64 field, and then we'll see what we get out as ASCII text. And it's not particularly meaningful, but we expected this because it's encrypted. So let's look around a little more and just see if there's anything more to this. So no other cookies. When we view the page source, it's pretty simple. A couple of basic scripts. So Bootstrap, jQuery. These are common frameworks. They're not going to do anything for us. Yeah, not much here. So you can start reading about homomorphic encryption, and it seems pretty cool. I mean, here's what they say. It's a form of encryption that permits users to perform operations on its encrypted data without first decrypting it. Which, again, sounds cool. For sensitive data, such as healthcare information, homomorphic encryption can be used to enable new services by removing privacy barriers, inhibiting data sharing, or increasing security to existing. Yeah, okay. This would all be great. And I'm probably going to throw in a little vignette showing just my frustration with all of these crypto nerd articles. It's like, this sounds awesome. Okay, you're describing something cool. You're describing something cool and the different elements that came out of it. You're talking about something cool. Show me a fucking example. Show me an example of this in use. You know, I went all the way through this. I went through the links they describe down here, Alice and Bob in cipher space. You show me cute examples. Show me how to do it. Show me how to do it.
No man, Persian or Greek, no man threatens a messenger.
You bring the crowns and heads of conquered kings to my city steps. You insult my queen. You threaten my people with slavery and death. Oh, I've chosen my words carefully, Persian. Perhaps you should have done the same.
This is blasphemy. This is madness.
Madness. This is Sparta!
What we're really hoping for is, and this is another link I clicked through, malleability, which is a property of some cryptographic algorithms. It's malleable if you can transform a ciphertext into another ciphertext that decrypts to a related plaintext. So as an example, again, because these guys, they don't give examples. It's like, come on, man. It's barely intelligible. All right, imagine, well, they do down here. Imagine you're telling a general what day to attack. If you can change the ciphertext so you can get, instead of Monday, Tuesday, Wednesday, or Thursday, something like that's a meaningful outcome. If you can just change it and instead of Monday, it's Monte, spelled with a T instead of a D, not super meaningful. So that's what we're looking for. And I got stumped. And I want to be honest with you guys when I get stumped, because a big part of this is learning, and so you can look at other people's solutions. So I looked at this guy's, and what he said was, he said he was tipped off by the fact that the letters CBC were capitalized in the challenge description. So he thought it was a bit flip, meaning there would be something in the cookie like admin equals 0, and then you could flip bits until you got admin equal to 1. Now I appreciate his solution, and it's going to sound like I'm just shitting all over it, but it's in Python 2. It didn't run out of the box for me. It doesn't really describe a bit flip, to be honest. He's changing entire bytes at a time, all values of a byte. So what I did was, first, super frustrated, stop using Python 2. Everyone, stop using Python 2. It's been deprecated for like 2 years. It's supposed to have been removed many years ago. It's terrible. So what I did was I brought over his code and I started to convert it, both to make it more readable and also to bring it to Python 3. So what we're going to do is, first I took my cookie. Let me make a little more space here. So I took my cookie that I got from the web browser that you saw earlier, and I'm doing a base64 decode. And it might actually be helpful if we just ran through this. So I will, there we go. So what we can see right now is we have something very similar to what we saw in the browser when I did the base64 decode. We're going to treat that as a byte array so that we can make modifications to it, because we can't just make changes to the raw field. I'll show you. This is more a Python thing than anything, but if we were to look at, say, the first element of the original cookie, if we were to try to change that, say to 81, to do our bit flip, it complains. It says byte objects do not support item assignment. So what we have to do is we have to wrap it in this byte array. And then all of a sudden we could make changes. So now you'll see original cookie is a byte array with 128 bytes. And if we were to try to change things, it accepts it. Let's change it back because we don't want that. So then I defined up here a bit flip method. We'll talk about that in just a minute. It's not really a bit flip, really it's a byte flip. All right, and then what we want to do is, for each byte that we have in our cookie, we want to check that position, and we want to flip all the different possibilities that are possible in there. So there are 128, just because it's a byte, so it's 8 bits, 2 to the 8, it's 128. So we're going to start doing that. And we will step in here. We'll make a copy of our original cookie. So just to show you this altered cookie, kind of like altered carbon, altered cookie is equal to the original cookie. Right now, they have the same contents. We're going to do an XOR with, again, so this is what you're trying to do. I'd like to show you quickly what we're exploiting. We're exploiting the fact that they're using a block cipher and they're using it on each byte, seemingly. And the problem with doing that is excellently described in the series of images. What they've done here is they have a picture of the penguin, and they apply to different blocks of pixels the same block encryption. And you can still see the penguin. Patterns remain after you've applied this, because what you really want is something like this, where it's pure randomness. And the way that you get that is, they describe it here, this method, it lacks diffusion, meaning it doesn't have an avalanche effect. So it doesn't incorporate anything other than each block. What you would like to do is you'd like to incorporate not just, each block, but all the prior blocks before it, so that someone who's attacking you, they have to figure it all out. And as we scroll down, you can see here's the way that you should be doing it, which is rather than just straight down through a block cipher, you have some component that goes out. So this is your plain text running across the top. So you could imagine admin equals 1, username equals Michael. These are different values that would be in these little boxes right here, going all the way across. So as you go to encrypt, yes, you're applying the same cipher, but what you're doing is you're taking the output of the prior cipher and you're chaining it. And so you get this avalanche effect where it's very hard to attack, because you have to attack everything, not just the specific area you're looking at. So what was described here, and I should rename this, we're not really doing a bit flip. What we're doing is we're looking at all possibilities of a byte. A bit flip would actually be quite a bit nicer, because we would only have to deal with each of the bits. So the operation that we're going to be doing above, you can see we're taking our altered cookie, we're taking a position from the altered cookie, and then we are going to XOR it. And I'm going to show you what that does. So let's look at the current position we're working on, which is 80. We saw that earlier. We're going to XOR it, and we're going to start with a 0. And that makes enough sense. XORing with 0 doesn't do anything. Next time we go through, we're going to XOR it with 1. Now we can see it becomes 81. So what's going on here? Well, if we look at the binary representation of this, we can see this is 80 in binary. And we are XORing that first with a 0. So nothing's changing. But then we XOR it with a 1. And what you're going to see is that last digit, that changed, because 0 XORed with 1 is 1. And if we did this with 2, again, you're going to see that digit change. With 4, you're going to see the other digit change. I'm going to jump ahead to 16 here, and you should see that one become a 0. And you do, see, carrying straight down. So this is what a bitwise operation would look like. Instead, we're doing all possibilities. So we're doing 15, 16, 17, all the way through, which really just ends up being trying every byte value for each of the byte blocks. So this is really poorly named, but that's what we're doing, and that's the intuition. And the hope is that one of these byte blocks is going to be a Boolean value. And so in the plain text, it would look like, all zeros. And we are hoping to change it to 1. Ignore the fact that it threw an error there. It's just for illustrative purposes. I don't care. All right, so we're going to flip. That's a meaningless flip. Meaning we could have left off XORing by 0, you know, but whatever. We are going to encode this back. So we should see something, yeah, very similar to our original cookie. See how it's JQR, and only the front has changed just a little bit. We're going to decode that as a string, just because we need a string when we create our cookie object. So we saw that cookie is the cookie is named auth name. If we go back here, I'll show you that again. In our storage, it's called auth name. And the way HTTP works is you send any cookies you have back to the server as part of the request. I covered this a bit in a prior video, which I linked earlier. But what we have to do is we're going to send a web request using the request library to the server, and we're going to include cookies. And we're going to keep changing this cookie until we get something meaningful. And how we figure out if something's meaningful is we look at the text of the response. So I'm going to go ahead and I'm going to step through here, and I'm going to show you what the text looks like. And it's the web page. So we expect at some point on this web page the words PicoCTF with a curly bracket to be in this text. And what I did here was, whenever you're doing something, like we're potentially going to do a lot of requests, and that could take a long time. And it would really, really suck if for some reason I missed the flag, because maybe they decided to make it all lowercase or something like that, or they accidentally included a space in there. Like visually, you'd be able to see it very quickly, but what we need to do here is we need an if statement that's going to definitely find it. So what I did was I just took everything to lowercase. I took the flag to lowercase. I also checked if there was a space. So we have an or. We're looking at two conditions. If we find the flag as we expect, or if we find the flag with a space in between. And so if we find that, then I want to print that out to the screen, and I want to stop looping. So that's what's going on. And I'm going to go ahead, I'm going to let it run. Setting a breakpoint down there. I made some modifications just to show you guys, which kind of screws around with the debugging tools. So I was undoing everything so that I could set my breakpoint right here. I'm going to press F5 to let it run and look at the terminal. And we can see right now we're checking cookie position 0. It's really important when you're doing something with a lot of operations that you have output, so that you can be sure that everything's still running. You can get a sense of how quickly it's going through. This is going to take a while. We are going to skip ahead in time. I'm going to fast forward. All right, perfect. So we have something where it matched, and now we should take a look and see what we got. So let's take a look at r.text, which is looking at the web page right now. And we can see right here, PicoCTF cookies yum 2D 0 to whatever. But maybe you're not satisfied with that, which is perfectly fine. Let's take our cookie and let's bring it back to the browser so that we can see the outcome there. Inspect storage. We're going to change our cookie by pasting it in. We are going to refresh. And there it is. And I'm going to complain one more time. So in challenges like this, like you never know if you're on as a person doing the exercise in the challenge. You don't know if you're going down the right path. And this is a lot of time and HTTP requests and everything else. You know, we did 13 times 128. If you just look here, we did 13 cookie positions and we did 128 requests for each of them. So we did something like 1,500 requests, and we could have potentially done up to 128 times 128, so like 15,000 requests. So I hate when problems don't end early. Like this should have been maybe the second or the third position, just because if you can imagine, if I made a mistake, if I did something like PicoCTF, checking for it, I could be waiting for like an hour to get my results, not knowing if you were just a terrible question writer and you put it like the 128th position of the cookie and the, you know, so anyway, it's just terrible. Let's go ahead, let's submit it, and let's be done with this one. All right. Thanks a lot. Have a good day. Like, comment, subscribe. Appreciate it. Bye.